So this evening, we have a presentation before our main presentation. Tessa Code and Paul Hillenbrand are going to talk to you about the Hawksbill Turtle Project.
I think I'm just going to speak and project because I'm not very good with microphones. So, my name's Tessa Code. I'm a biological science technician here at the park. And I'm just here to talk briefly and generally about our Hawksbill nesting program out on the beach. And then I'm just going to sort of hand it over to Paul, who's talking about our other volunteer opportunity that's going to extend from October through December. So we have 4 different species of sea turtles found at Buck Island. We mostly just focus on hawksbills and greens because those are the vast majority, although we do get some leatherbacks and some loggerhead sea turtles. Now, our program began because, well, we had a marine protected area that was established in 1961, and then there was the Endangered Species Act that listed many species of sea turtle. Before we had this program, rangers actually recorded sea turtle nesting behavior just using trees as markers. So the superintendent, he can tell you all about it, I'm sure. And right around that time, they were recording that 100% of nests were being predated upon by mongoose and rats. So there was a huge initiative to eradicate the mongoose and tree rat populations out of Buck Island, and they did it very successfully. We have no mongoose and no rats to this point, which has allowed our sea turtle population to flourish. Our saturation tagging program began in 1988, so we are doing our 29th year right now, which is very exciting. Very cool long-term monitoring project. A saturation tagging project means that we are tagging every single individual that comes and nests on our beach. So we're able to track single individuals' nesting behavior over their nesting lifetime at Buck Island, which is one of the only projects that can actually do that. So our typical night is we leave Green Key Marina around 6:15 and we start beach patrols around sunset. We have 3 people mostly on the beach. 1 person stays on the dock and each of the 2 others walk in opposite directions. Takes around 20-25 minutes. They wait at the end until the half hour or the hour mark and then they come back. We do it at that sort of time segments in order to encounter every turtle that comes on the beach, so that we see them either when they're coming out of the water, when they start nest hole digging. So we're able to then relocate every single nest that is laid on Buck Island, but also we can record failed nesting attempts where turtles come up on the beach, decide they don't want to lay for 1 or so reasons, and then go back down. So we patrol until sunrise, or the last sea turtles left the beach. Sometimes that's until 7 in the morning, 8 in the morning. We see a lot of beautiful sunrises on Buck Island. We're there pretty much all the time. So our turtle workup consists of a lot of different things. We're not just observing the turtles. We're checking their tag to figure out who it is, what their primary tag number is, or their name. We're then pit tagging them, taking biopsies of their tissues and their carapace to figure out genetics as well as diet. And then we're measuring them so we can maybe track growth over time, taking photos. And then we're making very exact measurements to then be able to relocate the nest after 50 to 60 days to determine hatch success, which Paul will talk more about. So just want to mention our workups are a little invasive to these sea turtles. We're not just looking at them or filming them. We're really trying to take samples to figure out in a much greater depth what our sea turtle population looks like genetically in terms of individuals and other things. So just a quick one, our project really couldn't be done without a lot of help from the Buccaneer, who houses our interns for the season, from our seasonal interns, and community support and volunteers. So we're hoping that we will not just scare you tonight, but also get you invigorated to maybe come out on the beach a couple times with us, and also NPS staff. So our sea turtle nesting population has increased over time. As you can see, we started with 12 individuals in 1988, and now we're at about 100. So in recent years, we've had some trough years and we've had some peak years. We're still trying to determine why that's happening. Those are still big questions for us. But the take-home message is we have more and more sea turtles every year, or the trend is still increasing. So This is just a quick aside that we know a lot about female sea turtles because those are the ones that come on the beach and nest, and we can really poke and prod them and do a lot of stuff to them while they're on the beach and laying their eggs, and they're in sort of a trance. So we satellite tag a lot of turtles with USGS and Dr. Kristen Hart, and we can tell you where sea turtles go for their foraging time. So they often travel really long distances to go and forage for the years in between, and then come back down to nest. So I have a really cool graphic that shows this is a hawksbill sea turtle. This is, where are we? This is Buck Island, where she comes and nests, and then she travels all the way up to the Bahamas, forages there, and then makes the migration all the way back down every other year, every 2 years. So it's pretty incredible. We know very in depth about what these female sea turtles do, but we don't know anything about male sea turtles. They're really hard to catch in water. They never come on the beach. So we are aiming our Hatchling Genetics project to try to learn more about these males in our population, because it doesn't make much sense to design management strategies if you're only really knowledgeable about one half of the population. So we're trying to gain at that big void of knowledge. So we are launching a Hatchling Genetics project, which Paul will talk about.
Good evening, everyone. As stated, my name is Paul Hilbrand. I'm a master's candidate at the University of Virgin Islands on St. Thomas, and I have the opportunity of working on my thesis project here on Buck Island. So we are going to be taking genetic samples from the hatchlings that are emerging from the nests on Buck Island. And the goal of my project is to, first and foremost, that's supposed to be white, identify individual males, and we'll be able to do this from taking the samples from the female and her genetic code and comparing it to the samples of the hatchling. And just like chromosomes passed down in humans, there are bipaternally genetic information passed down to the hatchlings. So when we compare the hatchlings to the females, we'll be able to see what genetic material is passed down from the female, the mother, and then whatever the second genetic material that is unidentified is left over from the male, and we'll be able to identify that as the father. And so we'll get a good count of how many males are actually contributing to the population, which, like Tessa said, will hopefully improve our management opportunities of the species. The second is to test for multiple paternity. So sea turtles mate with multiple partners in their mating season. So one nest, there could be two fathers responsible for one nest and with one female. Does that make sense to everybody? Fairly straightforward. The other one is to determine an operational sex ratio. So right now we can only determine sex ratios on juveniles, and that is through a blood test. Knowing how many males are contributing to the population will allow us, again, to do better management practices, and we can see how many males and females are sexually mature in the population. And this goes back to climate change and potentially warmer temperatures causing nests to be female biased, because sea turtles are their sex is dependent on temperature. So in a nest, on the bottom, it's going to be much cooler than on the top where the sun's hitting. And so the phrase goes, hot mamas and cool daddies. So on the bottom, you're going to get mostly males, and on the top, you're going to get a lot of females. So with temperatures rising, it's going to get hotter through the nest, and those nests could be potentially female biased. And we want to see if there is, in fact, an effect on that. And then the fourth one is going to be reproductive success, and that is only going to be opportunistic if we have enough time. In order to do that, we have to take every hatchling from every nest, and that just takes a lot of resources. So right now, the only goal is to take 32 samples, or 32 hatchlings, and sample them from one nest from each female to get a good variety. Oh, that's what it is. So now I'm going to show you what's going to happen on the beach. So in box A, this is just a simple sampling station. So if you come out, this is where everything will be set up. We'll have a box with all the supplies. In picture B, we're going to have every sample, this needs to be bigger, we're going to have every sample in a little vial, and so those are going to get saturated salt solutions to preserve each sample from the hatchling. And then we're gonna spray alcohol on the right front flipper of the hatchling, because this is where we're going to take the tissue sample. And if you can see right here, that's how big the tissue sample is going to be.
Super small.
1.5 millimeters. It's a little less invasive than everything we're doing for the females. And we want to do it on the trailing edge as close to the body as we can, because we don't want to hurt any of their phalanges. They have a bunch of bones in here that we could potentially mess up. So we're going to try and get it. I say put your thumb right next to the body and then take your tissue sample right against your thumb. And that should be close enough, far enough away from the body, but close enough in that you're not going to hit any of the bones. Sample, or box F, or E, sorry. This is putting the samples in the sample plate. Just, again, they're really very, very small.
Oh.
There we go. And then after we take the sample, we're going to apply a hemostatic agent to prevent and slow bleeding if there is any. Normally there isn't. They're so small that the capillaries aren't there yet, so they normally don't bleed. And then in G, I don't know if you can see, but this right here is about how small the tissue sample is. So again, it's a little less invasive than what we're doing with the females. And then in box H, after we sample them, we're going to go ahead and let them hang out in a box full of sand until we get done. And then we have three options for releasing them. You can either release them right when we're done sampling, about a couple meters higher than the high water mark on the island. We can go back to the nest and let them loose there and kind of do their natural process of going from their nest into the water. Or we'll take them out on the boat at the end of the night or in the morning and release them by the buoy in the channel so that they can be free and on their way. And we want to release them in large groups so that predators can't just pick them off one by one. And it's kind of like the reason that so many, or there are 100+ eggs in a nest, is so that they can get out there all at once, and that's why they say only 1 in 1,000 make it. So it's kind of like a burst method. Hopefully we send 100 out and at least one makes it to sexual maturity.
So for volunteering, we have 2 chunks of time. We have this time in September, where if you come volunteer with us now, we will be keeping you out all night from 6 p.m. to 6 a.m. But you will be able to participate in the Hatchling Genetics project and also the nesting females. So longer time, but you know, a variety of experience. And then starting in October, it's just going to be 6 p.m. to midnight for just the Hatchling Genetics project. Now, just a moment for me to scare you really fast about what Buck Island has to offer. We are scrambling over very slick rocks. We are walking over uneven cobble. We are walking on very deep sand and in the beach forest where there's manchineel and things that'll prick you, sting you, make you itch, make you hurt and cry. It's not that fun all the time. We get rained on, sea turtles bowl you over, slap you. Yeah, so really we are expecting an amount of physicality with people who want to come out with us. We walk up to 9 miles a night. So I think everyone who wants to volunteer, I really want lots of people, but you need to know that you're able to do the work if you come out with us. So also it's all at night, so it's dark, so you also need to kind of have good night vision. All that being said, we have note cards over here. If you're interested, please write your name, your contact information, and your potential availability. And depending on the numbers that we get, we'll send either a mass email or I'll send instructions to sign up for volunteering. And we'll have sort of another session where we again talk about the ins and outs of what we're doing out there, just another out in case someone decides that they don't want to go out before we take you out on the boat. So that's what we've got. We'll be over there for questions so we don't take up any more time.
Repeat the time again, the schedule.
Yes, in September, we go out every night. So it's 6 p.m. to 6 a.m. And in October, it'll be 6 p.m., 5:30 or 6 p.m. until around midnight every day. So that's what we've got. Perfect. Thank you guys, and thank you for letting us come here.
like to introduce Marlon Hibbert with NOAA, marine scientist and coastal zone management, and you're going to talk to us about climate change and how our future might look.
Yes.
Thank you.
Rick, do I need to use the mic?
Back row, can you hear him? Or would you like him?
Can you hear me fine?
Okay.
All right. So if I start to, if I don't sound audible to you in the back, please let me know and I'll pick up one of the mics. But I think I have a big enough mouth to let you hear me. So as Julie said, I am Marlon Hibbert. I work under contract with the Baldwin Group for NOAA's Office of Coastal Management. My significant role in the territory is as the Coral Reef Conservation Management Liaison and the Coastal Zone Management Liaison. So my dearest and best friends are in fact DPNR. The Office of Coastal Management supports the St. Croix Eastern Marine Park and the Coral Reef Initiative and the Coastal Zone Management Program through both financial resources and technical assistance when needed. So I am that go-between between NOAA headquarters in Silver Spring, Maryland and the territory. So anything NOAA, people usually say, okay, Marlon, can you find someone in NOAA who can assist us? We need some flights, we need coast and survey. So I'm sort of that person who says, all right, I don't know anything about what you want, but I'll send an email, I'll pick up the phone. When Suzanne called me to talk about climate change, I thought to myself, wow, I'm digging myself a hole. And I thought to myself, well, I can bore you with a lot of information. I can go and say, well, I'm going to show you everything there is possible on climate change. I decided not to. I decided rather to have the sort of presentation where it stimulates your thought process towards discussion. So I'm not going to give you all the dreary, gloomy figures of the predictions of climate change or the reality of climate change. What I am going to do is present you with some facts. We're going to have a discussion about it, and then at the end you can grill me, or as Mr. Tutan said, he has a bag of tomatoes sitting at the side. So I played, how many of you played Dandy Shandy? Well, I call it Dandy Shandy. It's dodgeball. So I'm pretty good at it. So, all right, I'm pretty good at it. All right, so what have been the most recent climate happenings? Well, recorded 2015 was the warmest ever year recorded on land and in ocean. And this year, there are some projections that 2016 might surpass that. The previous record before that was 1998. And for those of you who spend a lot of time in the water, 1998, 2005, 2010 were very bad years for some of our resources in the Virgin Islands. I'm sure some of you may have heard of the term bleaching and have seen it yourself. Well, this year we are on track, and we hope not, that we could in fact have bleaching events this year, later on in the year, maybe in a month or two's time, around the Virgin Islands. We are on a bleaching alert watch, and I'll give you some resources that you can go to and look at the predictions. Last year we had an event, the Paris Agreement, not the bombings that happened in Paris, but shortly after, there was a huge meeting of over 180 countries in Paris that came together to do something globally about climate change. And they signed this agreement called the Paris Agreement, which says that they're going to try to do three main things: reduce carbon emissions, give enough money so that the most vulnerable countries can access it to adapt and mitigate against climate change. And three, to provide information to the most vulnerable in the societies across the world about the effects or the predictions of climate change. Today is the 8th of September. 5 days ago, 5 days ago, China and the US decided, we signed the agreement, we're now going to ratify the agreement. On the books, 180 countries signed the agreement. Only 24 have ratified. For the agreement to go in force, as in take effect and be implemented and start the implementation process, 55% of that 180, or 55% of the global emissions producers have to sign. By China and the US signing or saying that they're going to ratify formally, 38% was covered. China is at 20.89% and the US is at around 18%. So 38% is covered by China and the US alone. Rest of the countries are, of course, your India, Brazil, Argentina, Australia, with smaller portions. But if all those countries follow the lead of the two largest contributors to the emissions, we will have that sometime, hopefully by the end of the year. Something very worrying happened in 2014 and 2015. We had 100% of, and I'm not going to read it, but all US coral reef areas, so from the Caribbean to the Pacific, showed some signs of bleaching thermal stress. It started in late 2014 and it has continued. So for almost 2 years we've been having a significant warming event. I'm sure some of you have heard of what has happened in the Great Barrier Reef. That is part of it. Fortunately, I just saw today that it's cooling back down and they're getting some relief. Globally, that 100% of US coral reefs goes globally, 99%. So not just US reefs, but globally, 99% of all reefs had that thermal stress. El Niño, one of the reasons why, and I'm so sorry about the quality of that picture, and I'll try to explain it. So we have two particular things that happen. The El Niño Southern Oscillation, or ENSO as it's called, is this area in the Pacific. It's hard to look at, but we're over here, this is the Pacific. And because of heating, so warmer waters and higher temperatures, so we have a cooling effect. It causes warmer than normal temperatures on the other side. La Niña is the opposite. That significant event, those two significant events, trouble climate. I wanted to make a brief distinction. Climate and weather are two different things. Climate is global, weather is localized. So the weather here in Christiansted can be different from the weather in Frederiksted. But the climate is the same. So those two significant effects trouble climate, not necessarily weather. Just to give you an idea of some of the effects of what El Niño can bring to the Caribbean, and some of which we might be feeling. Mr. Tutan and I were in the laundromat the other day, and the heat was on. And he said, climate change, no, it's not happening. But if you are, and you don't need a thermometer to be walking around to realize something is different and something is changing. There are days when it feels like it's 105 and something is changing. We have higher dry season temperatures. Now, our dry season is normally December through April. But along with dry season increase in temperatures, the other effect is precipitation. So we may actually get more water during a hotter time. The consequence of that is humidity levels go up. You have, and unfortunately, it is the time we have viruses such as Zika who love those types of conditions. So again, what we're seeing are shifts, variability. So the climate is changing, but we have greater variability in localized weather conditions, which may lead to increased public health concerns. That's one very important fact that can happen from climate change. So this slide is really just to give you a rundown, some brief points of what are the possible concerns. We have melting polar ice, which if you go again and search, you will find wonderful pictures of glaciers in the late 1800s that are now looking like no longer glaciers. They were covered in ice and now they're bare ground with grass growing on them. So it is changing. We spoke about, remind me of your name, please.
Tessa?
Tessa spoke about migrating turtles. Turtles are not a Buck Island resource. Buck Island is their resource, but they are not Buck Island's resource. They are a regional and global resource. I'll give you a very quick story. When I worked in the Turks and Caicos Islands, we tagged a large turtle, huge. She was 300 pounds, named Susie. Tagged her. And she came all the way to St. Croix and spent 6 months. She nested in the Turks and Caicos, but she spent 6 months at the Cruise and Rum effluent eating. So she came for food because there's lots, right? But she came, so she was a regional resource because she came down, she went down to Guadeloupe, Martinique, came back up, went over to Anguilla, BVI, and then settled in St. Croix for a little bit. There was a common joke in the office that she was a British turtle because she went to all the British overseas territories first, before. So we have those issues where species are going to move according to the conditions that enable them to survive. Presently, and we're talking about, I know many of you are aware of the invasive species issue. Prime example being lionfish. Here, we have them here. Now there's another invasive that's on the horizon. It's not here in St. Croix yet, but it's in St. Thomas and in St. John. And it's a seagrass species called Halophila. Now we aren't really sure of what the effects are, but again, it's a possible effect of those changing scenarios that we're facing. New and widespread diseases. Chikungunya and Zika have been around for a very long time. They're not new. But the spread has been forced by one, global movement. People are moving all the time in response to changing conditions in their own environment. We have damaged crops. We only have to look last year, and we'll get to it some more. We only have to consider last year on St. Croix. The severe drought that we faced. And though, fortunately or unfortunately, we import 95% of our food resources. So fortunately, we still had access to food. But let's say we had had all our domestic food production happening on St. Croix. That would have been a serious disaster, because now you would have had to have gone to negotiate food supply lines to get that food in for the population. That's one way to look at it. Now, if in another region of the world we have a cutoff of that food supply, a drought condition is not producing enough wheat or corn or whatever else it is, and we import that, then our reliance on ourselves become very important. And those are things that we have to plan for in the changing scenarios. An average precipitation increase around the world. This is a conundrum, because there are some places in the world that are not going to get any water. And there are some places that are going to get too much. So the balance is hard to predict. Monsoons, Louisiana, for example, an effect of possibly of El Niño, because it was supposed to get wetter in the southeastern United States because of El Niño. Drier in California and the west coast, wetter along the south and eastern coasts. Droughts, heat waves, extreme winters, storms, hurricanes, typhoons. There are two levels of thoughts on those things. One, you have more of them. Two, you have less of them, but the ones that do hit are going to be much stronger. So we haven't had a really bad one in almost 30 years. Yes, in 27 years, in almost 30 years. Right? And it was bad.
I remember it vividly, like it was yesterday.
We haven't had one in that period of time. We've had near misses. We've had some pass over and go to do even worse damage on the mainland, on the contiguous states. But they were strong, and they cost. For instance, this is a picture of a farm, brown ground with smattering of water. This was taken last year at one of our local farms. And just recently, about a week and a half ago, there was a forum at UVI hosted by NRCS where the USVI is advocating to be added to the US Drought Monitoring Forum. So there are drought monitoring stations across the contiguous United States and in Puerto Rico, but the Virgin Islands is not in it. And so predictability, any predictions we make have to be from Puerto Rico. So this is what that was about, an important aspect of learning to see what's happening within our own localized area. And it gives us a better idea of how to plan for that. A bit of reality. We talk about the changes, ocean acidification. We are proud of our heritage as a maritime country. We love the water. It gives us almost everything we need, from mental, spiritual, social, and economic well-being. There are some changes that are happening that may throw this balance off. One of which is ocean acidification. It's become more important over time because there are now more advanced techniques, scientific studies being done to say, well, 0.1 pH unit doesn't sound like much. The 30% is what is important. Even that 1%, that 0.1 represents a 30% increase. What it means is that on land we have forests, plants, they're the primary producers. The cows eat them, we eat the cows. In the sea, those primary producers are the small algae that we can't see, but most of them have a skeleton made of calcium carbonate. We have the reefs that provide the fish, which are also carbonate skeletons. That rise in acidity could potentially, and has been proven in laboratory studies and small-scale studies in the field, that there is a huge change, and we're seeing the effects already. What we're talking about, when you look at it globally, is a collapse in fisheries. And globally, that means people can no longer afford what is cheap protein. No longer will you be able to throw a line for someone who can't buy it, but his only source of protein is going to throw a net or a line to catch the protein that he and his family needs. If there's a collapse in that, that's a potential issue. Nutrients and temperature. I found this today while preparing, and I dropped it in because I thought it was very, very important, because this is something we face on the island. Coastal runoff. The last rain we had, I stood up and watched a brown plume migrate from Gallows Bay across to Hotel on the Quay and out the harbor mouth. What's happening, and what this is saying, is that there could be, and again, the science is emerging, that there could be effects from what is in the water going out and how it affects the reproductive nature and vigor of our beloved coral reefs. The early life stages, and this was done, this particular study was done on a species not in the Caribbean but in the Pacific, but a similar species that we have here, Acropora, one of the acroporid species, fast growing and reef building corals. Another graphic that I wanted to share, and again, it looks much better on my computer than it does up here, but this is in fact Christiansted.
Do you want to reduce the contrast?
Yeah,
We
maybe.
can do that right here. Let's see, let's just menu. And then we go
Contrast.
go over, go down to contrast. Go down, or do you want to go up? Which way? Is it improving? Which way?
Down.
No, okay, go down.
All right. So, so we're here. This is a scenario where the sea level rise will be about this. No, from the tip of my finger to the middle of my chest. About 3 feet. That's the scenario if we have sea level rise of 1 meter. This is the historic site here. This is all the boardwalk underwater. Rum runners underwater. Shoops underwater. Brew pub underwater. Rum runners underwater. And us stepping out of this building.
Marlon, that's when the superintendent kayaks to his off.
and us stepping out of this building after another friends meeting into water. And this is a projection, not a reality, but consider even if we get half of that and we get a very high tide and a little breeze. What we're looking at is coastal inundation. And this is an old model. It's not as accurate as the newer models, and we're working on trying to get some newer models. But why is all of this important? I come at it not from the perspective of a pure science, but my role is really how to deal with it in a management perspective. What are we going to do as a community? How can we help the people who are in charge of policy to make the right decisions? This is some very new data released this year. It hasn't come out officially, but I asked to share it and I was told you can go ahead. The ocean economy, and this is a product that NOAA produces called Niño. Look at this figure. So anybody who is related to the ocean, doing charters, be it accommodation services, retail services, shipping, is caught in this. 19% of the total. Probably the second highest behind government. And you could say that they are also involved in the ocean economy because they are servicing many of the people. They are servicing us who are involved in the ocean economy and the people who are coming in. This was just newly done for both Puerto Rico and the Virgin Islands. These are the low estimates here, and these are the higher estimates of the amount of people employed in the ocean economy. A little bit more about that particular product. They look at three things: living resources, marine construction, transportation, offshore mineral resources, ship and boat building, and tourism and recreation. And these are the figures, some of which were released and some which were not. But these figures say that this ocean economy contributes almost $175 million to the economy each year. So related just to ocean, be it us carrying somebody on a journey out to Buck Island, or going fishing on the drop, or kayaking in Salt River, and providing them with reality services for who are looking for their piece of paradise, or your vacation rentals. One thing is certain, that most people come for a bit of sun, sea, and sand. And this is cruise-related tourism. And again, I wanted to bring it home because of the potential effects of our changes in climate on the resources that we have that provide these things to us. And we're looking at total expenditures, and I can send that to people who are interested in looking at. It's 70 pages. I just took out 3 pieces of things. If you're more interested in looking more detailed at it, I can send it to you. It's public money. It's free for you to look at. Storm costs. So in the scenario that we have changing climates, stronger storms, the 5 C's looked at the economic impact of one season, a very active season, 2004. 2004, 2005 was a very active hurricane season. We haven't had one of those in a real while. We're talking Katrina, Wilma, Dean, who else? I think there were 4 or 5 that year alone that went on to do significant damage. And Ivan. And Ivan. How could I miss Ivan? Ivan is the one that tore apart Grenada and Cayman. What's important, look at these 2 figures. Not that. That's a lot of money. But all the money that was produced in both of those countries were exceeded by the cost of the storm. The recovery from things like that takes you, how long? 27 years?
We'll never recover.
Some people will say that. We've not recovered. We've never recovered. Maybe we never will. But this is what an increase in intensity of storms exacerbated by changes in climate can bring. Changes to our social fabric that are just as important as what they're going to be doing to environmental fabric. And where people are, where their social structure is disturbed, there is less empathy for what natural resources. So there's a knock-on effect, there's a domino effect. If you are struggling to feed your family, the last thing you want to hear is that is a protected area. I want to be out there trying to feed my family. I titled this In the Race, or DQ, which it means disqualified. In an ode to the just recent Olympics and the ongoing Paralympics now. And this is what Sean Michael Malone had to say, that we are very behind on climate change. And he made a very good point. We've got to get ahead. And one of the key things is educating our populace about what those potential effects are and what we can do to plan and adapt to the changes that are going to occur. For example, the picture I showed regarding inundation, coastal inundation. Now we can't take up King Christian Hotel and move it. It's never going to happen. It will not happen. But if you are going to engage in new construction in this area or any area along the coastline, for example, wouldn't it make sense beforehand to say, okay, what's my vulnerability? And if it means moving 150, 200 feet extra inland, it probably will save the cost of your construction over time. Because if your building gets swamped, you leave a white elephant sitting down. Or if it gets blown down, or it's eroded to the point where your structures start to fall into the ocean, but moving 150 feet might prevent that. Mr. Jean-Pierre Auriol, and this statement came from a meeting in Guam in June of last year, and he put out the challenge. So how are we going to integrate climate change into our everyday lives? It's happening, we need to be aware of it, but we also need to figure out what are the things that we can do within our own context to change. There are many people who will say, but the Virgin Islands produces zero of those carbon emissions. Why should we even be concerned? The point is that 38% is going to affect us first. We are the most vulnerable because guess what? We have nowhere to go. People in Miami can take the bags up and drive up to Georgia and say, all right, we're away from the coast. The Virgin Islands, some of us are stubborn. We're not going to move. And there are so many of us that can hold up on top of the mountain or on Goat Hill. It is the reality. I say it in jest, but it is the reality. Many of us will not move because this is our home. So we must look at other ways in which we can either retreat, which is mitigate, or we defend, which is we adapt. So are we going to put up seawalls along the Christian Thread boardwalk? Are we going to raise the boardwalk? We just spent $3 million on it a few years ago. Are we going to tear it up and lift it up? Lift shoops up on stilts? Again, I'm playing devil's advocate because I wanted to stimulate our thought process and our discussion about what it is that is facing us. And not just us, but 20 years down the line, 30 years, 40 years, in 2050, most of us are not going to be around. But our kids and grandkids. Yeah. So what are the local actions that are taking place? So you may have heard that the governor signed an executive order in 2015 about climate change. And the major thing that comes out of it is that he has asked every single government entity to do a vulnerability assessment of their department and all the things that they are responsible for. So they have to do a vulnerability assessment. I know we're behind. I'm not going to mince words. I know we're behind, and it's not yet done. There were some timelines, and we're behind those timelines. Part of that executive order, the Department of Interior, through the Office of Insular Affairs, has provided some funding. That meeting that they went to in Guam in June was a meeting of all the states and territories. So the smallest of the small came together to talk about how they were going to tackle this very big issue. And there's a climate change coordinator in the Office of Insular Affairs who is helping the territories to, for want of a better word, to get their act together. All right, so we have a climate change coordinator now in the Virgin Islands. There is a climate change council that has been formed, and they are meeting, and they are the ones who are supposed to drive the process of us planning and getting the information together that we need to get to the public to say these are the things that we are doing now. Caribbean Regional Ocean Partnership. That's a partnership between the US Virgin Islands and Puerto Rico. We share a common area, and it also involves the British Virgin Islands. We're a little isolated, but Puerto Rico and the rest of the Virgin Islands and BVI sit on one little piece of bank. All right, we're a little isolated, but we're still a part of it. And so this partnership is about us looking at our common resources and saying, okay, where are there things that we need to be working together on? There are some brochures in the back you can take on the Caribbean Regional Ocean Partnership, and there is in fact a portal that you can visit and get some more information. I spoke about the formation of a Climate Change Council. Another thing I wanted to mention was before Governor DeYoung left, Richard Branson had this huge event on Necker Island in the BVI. And he invited the heads of government of about 20 Caribbean countries, including the Virgin Islands, to sign what was called the Caribbean Challenge. And the Caribbean Challenge has basically one main focus: to provide and to improve the level of funding for protected areas, but also, I think, by 2020 to have each country have 20 by 20. So 20% of marine protected areas by 2020. Technically, the Virgin Islands has surpassed that, but they haven't signed the agreement. But it also, if we sign, it also allows us to gain access to funding to help us manage these areas. And of course, vulnerability assessments. There are products out there that you, as an individual, can look at your own vulnerability to the effects of climate change. So, where's my house? How close is it? What would be the storm surge run-up if we had a heavy storm? What would be our scenario in 1 meter, 2-meter sea level rise. There are products out there that you can access, that you can look at your own vulnerability in those cases. And I wanted to just touch briefly on something that happened in 2015. So we had an exchange where we had a climate change in the Caribbean conference where we exchanged ideas in this region. Puerto Rico is ahead of us in the work that they're doing, and rightly so. They have 40 more universities than we do. Many degrees of population more than we do. So they have the human resources that we don't necessarily have. Right now they have no money. So that makes us equal. But they have some more technical resources than we do. So why not learn from them? There's no need to go start reinventing that thing called the wheel. You know, we can all share. So that was the event that we went to, and we had the governor's representative, we had the people from DPNR, we had UVI, we had community organizations coming over, learning, looking at public health, tourism as it relates to climate change. I'm going to close shortly, and it is, can you help? Well, you can read that, but really what it says is yes, please help, get involved. This is commonly quoted in the context of environmental justice, but the Rio Declaration says are best handled with the participation of all concerned. So there should be no sectors of our society that do not have the requisite information on which to act. It's the same when we're planning for a hurricane. VITEMA doesn't give the information to a certain sector. They give it to all. With that information, you have a choice. You can act or not. This says that this information about the changes that are possible from climate change should be shared, and everyone should have a chance to make an informed decision about what they do and how they do it. And in closing, some things that we can do potentially. This is an earth change, a culvert. That's the ocean. Not very well done. Those are things that we can do and hold people accountable for. If you're building, those measures by law should be properly placed. If they aren't, then we have a problem, because runoff from here goes one place, and that's there. We have lots of unpaved roads. Land-based sources of pollution, as we were looking at, can make the effects of climate change more. There are two cases I wanted to look. So this is good, this is bad, this is bad. Good, this is Golden Rock. That place beside the, what was it, Toro, I think? The place beside First Bank, in between First Bank, yes. First Bank, and in the demolition phase. So it's a good example of retaining what you want on site. Detention pond, lined with rocks, and a well-placed turbidity, sediment curtain to retain, if there is water, to retain the runoff. And here, Zandi would know this project really, really well, because she was a volunteer. A driveway disconnect project. Some extra space on your property, so rather than let the water run off onto the unpaved road, it was redirected into a catchment basin where plantings were. So a rain garden in essence. Low cost, and with a group of persons helping you, easily done in a morning. Was that day? Yeah. And there are some resources that I'd like to share with you. You can take a picture, write it down, but NOAA has a lot of products on Digital Coast. Just remember one word, Digital Coast. Just put NOAA Digital Coast, and you can go and look at the Coastal Flood Exposure Mapper. You can look at eNow. You can look at the Coral Reef Conservation Program, Coastal Zone Management Programs. An important resource that probably isn't heralded, but this is the Caribbean Institute of Meteorology and Hydrology. If you want 3-month weather predictions, precipitation, drought, that's the site. It's a group of people, NOAA involved, Puerto Rico involved, the Virgin Islands involved, and the rest of the Caribbean that come together at least once a month to meet and make these predictions. Drought monitor. Hopefully the USVI will be there soon, but again, another resource that you can look at. Coral Reef Watch, I mentioned that earlier. This is where you can look globally about what's happening. Right now we're in a bleach, we're not at alert level 1, we're bleach watch. Bleach watch, but you can go in and look and see how many weeks of heating we've had over the last month and so on. The longer the water heats up, the more risk we are at the corals bleaching. The Puerto Rico Climate Change Council. Useful information because they're right next to us. They face many of the issues we do. Hopefully very soon we'll also have a portal for the USVI. Caribbean Climate, that's the 5 C's, which is the Caribbean Community Climate Change Center. It's called the 5 C's. So if you don't write it down, just remember 5 C's. And you can search for it. Again, another good resource because our partners in the Caribbean are facing the same issues that we are. One of the very good things about the Virgin Islands, believe it or not, we are way ahead in water harvesting, which is an important adaptation to changing climate. Many of the countries in the Caribbean did away with cisterns, did away with catchments. The Virgin Islands has retained that, and because of that, we are way ahead of Puerto Rico in that regard. Because when they had the drought last year, much of San Juan was under 1 hour and 2 hours a day for water. Jamaica, the Kingston metropolitan area has 2 reservoirs, each holding 800 million gallons of water. They were down to 30% each. And in the metropolitan area of Kingston, 1 million people. They're not small. They had to go down to 1 hour in the morning, 2 hours in the evening. So water rationing. Some of us, we suffered, but if we were careful and conserved the water, many of us weathered the storm through the drought with our cisterns, which we are way ahead in that respect. And then of course, climate.gov, which is also a NOAA site, can give you some more information as well. I'm done.